Hello everyone, so today's video is going to be on molarity and dilutions. Okay, we're going to go ahead and start off with the concept of molarity and consider molarity as being pretty much concentration of something. Think in your own personal lives, like when you've had to mix a drink, maybe chocolate milk, maybe Kool-Aid, and if something is really strong, then you say that it's highly concentrated. So we tend to add water, and that tends to dilute whatever it is that we're drinking. Okay. In terms of molarity, guys, we're going to talk about moles per liter. So our equation or formula for molarity is M is equal, M being, or capital M being molarity, is equal to moles divided by liters of solution. The moles are going to be of its solute, whatever you may use, sugar, salt, whatever the case may be, and the solution may be water or some other type of liquid. Okay, but that's what we're going to start off on. Don't forget that if you have any questions, please contact us through Teams, through our email, through Remind, and we'll be more than happy to answer any of your questions. But I'm hoping that this video is going to make things a little bit clearer on what to do in your Nearpod. Okay, so when we look at molarity, we're looking at pretty much three variables. We're looking at capital M for molarity, moles for moles, and L for liters. Okay, there's really one main equation or formula, but mathematically we can manipulate it two other ways. So if we're trying to find molarity, it's going to be moles divided by liters. If we're trying to find moles, then that's going to be equal to molarity times liters. And then last but not least, if we're trying to find liters, then that's going to equal to moles divided by molarity. So let's go ahead and take a look at our first example, which is also an example that you're going to find on Nearpod. It says calculate the molarity, again remember molarity being the concentration, of a solution prepared by mixing 1.5 grams of sodium chloride, NaCl, in 500 milliliters of water. Okay, keep in mind, you need to remember that we only are dealing with three variables, and out of those three, one of them is going to be an unknown. So first of all, let's go ahead and take a look at what's given. Okay, one of the givens is going to be the 1.5 grams of sodium chloride. So you might be asking yourself, what? Mass? So how am I going to be using that? What is that? How does that interpret into this equation? Where does mass go into here? Well, no problem, because we can convert that mass into moles, and I'll show you how. Okay, so the first thing we've got to do is to calculate the molar mass of sodium chloride. I don't know if that either brings good memories or bad, but we've done that in the past several times. Okay, so here we have sodium chloride. The fact that it doesn't have a number here next to it, or a subscript, that's telling us that it's only 1 mole of that specific element. So 1 mole of sodium and 1 mole of chlorine. Okay, and as we're calculating it, okay, remember from prior to us doing all this, when we did it with stoichiometry, molar mass, and all that thing, all those things on conversions, we went ahead and laid it out in this format. So it reads 1 mole of sodium. Where did I get the 1 mole? Again, because there's no number here, we assume that it's 1. Multiplied by the mass on the periodic table. Again, so here's a periodic table that you guys were given, and we're going to take a look at sodium. And if we look at sodium, okay, you're going to see that the mass is 22.990, which I'm just going to round to 22.99. Okay, and there it is. So I'm going to multiply the 1 by 22.99, and it gives us, again, 22.99. You do the same exact thing with chlorine. I know that I have 1 mole of chlorine because there's no numerical value here. It's understood as 1, and I'm going to multiply it by the mass on the periodic table. So again, you take your periodic table and you look up the mass for chlorine, which is right here, 35.453, which I'm going to choose to round to 35.45. Okay, once I do that, just like I did above, I'm going to go ahead and multiply 1 times 35.45, and there it is. Okay, once I get all the elements that are in that particular compound, I go ahead and add up those numbers, and I get 58.44 grams per 1 mole of sodium chloride. And that's going to be our molar mass for sodium chloride. So now the question is, how do we get that molar mass to be converted into the moles, which is what we need? Now we have this number, and then we also have this number, which again does not interpret to moles, but no problems because we can convert it using dimensional analysis. So we're going to say we have 1.5 grams of sodium chloride. That's what we know we have. So how do I convert this to moles? Well, remember I said we're going to use our molar mass. That's exactly what I'm going to do. I know that in 1 mole of sodium chloride, I have 58.44 grams, which is what I calculated. Okay, so in dimensional analysis, remember that like units have to be diagonal to one another. That's how you know that it's set up correctly. So in this case, it is diagonal. I go ahead and cancel those units. And if I do, what that gives me a remaining unit of moles, which is what I want to find. So essentially what I'm going to do is take 1.5, multiply by 1, and then divide that by 58.44. Once I do that, I'm going to get an answer of 0.026 moles, again, because that's not the one I canceled, of sodium chloride. And again, this is going to be one of the variables that we need. Remember, this is a formula we're working with. Molarity is equal to moles per liter, and we just finished finding this one. Okay, and just in case you didn't get how that interpreted mathematically, don't forget, what I did was take 1.5, multiplied it by 1, and then divide by 58.44 to get that 0.026. All right, so this is what we have to work with so far. We know that they're asking us to calculate molarity, so that's our unknown. We know now that our moles, because we converted this grams, is going to be 0.026 moles. Now the only thing to find is that liters, okay? They give us 500.0 milliliters. So how does that become liters? All right, so we know that in our formula, it's asking us for those liters. And we really need a number that is being expressed in liters, not in milliliters. But again, easy fix. So we convert the milliliters to liters. Okay, we have to have a conversion factor. In 1 liter, we have 1,000 milliliters. That's what we know, or we should know at least. Okay, so now how do I convert that to liters? Okay, you can use dimensional analysis. We know that we have 500 milliliters, and we know that in 1 liter, we have 1,000 milliliters. We cancel like units. We multiply 500 times 1, divide by 1,000. Okay, that would give us 0.5 liters, which again, it's another variable that we need. In the event that you want to save yourself some trouble, if you ever wanted to convert milliliters and liters and such, you could have also done this, shifted your decimal. So I know the same conversion factor, 3 zeros, I'm going to go ahead and shift that decimal in the 500 to the left 3 times because of the 3 zeros in 1,000. Decimal lands here. So now that's 0.5 liters. And again, this is just in case you didn't want to do the dimensional analysis here. Nonetheless, it is the liters that we needed. Okay, so if you look at everything, everything's coming into play. We have our 3 variables. One of those is our unknown, and we can fill out this formula. Okay, so we're going to take our moles, substituted by the value, the number value, which is 0.026 moles, divided by the liters, which is 0.5 liters. Do the math, divide the 2, and you're going to find that your calculator is going to spit out 0.052 moles per liter, which in any case, guys, understand that this right here is the same as the unit M. It's just another way of writing it. So you can go ahead and write it as 0.52 molarity. Okay, so that's pretty much the answer to our first example. Let's move on to the second one. Okay, for our second example, it's asking or saying 965 grams of sodium hydroxide I used in preparing a 1.5 molar solution. How many liters of solution can be made? Again, keep in mind 3 variables to work with. We have molarity, moles, and liters. Okay, and from the information given, okay, we have 1.5 molar solution. So we're going to put it for M. Okay, and they give us 965 grams. Again, from the previous example, we know we can use moles of and grams together where we convert one to the other and vice versa. Okay, so we're going to convert those grams to moles. And then, of course, you know, we have our unknown. And in this case, they're even asking us here in the question, how many liters? So we don't know what that is. Okay, so if you remember from earlier, I said that there are different ways to go ahead and calculate, you know, different variables. And if you recall, I said that you can manipulate or rearrange the letters in the formula to find out your unknown. So since we're looking for liters, we know that liters is equal to moles divided by molarity, which is what we're going to do. But the first thing we have to tackle is to convert this 965 grams to moles. All right, to do that conversion, we've got to first find the molar mass of sodium hydroxide, of course. Okay, same procedure that we did before, okay? So using your periodic table and using the formula that's given to you. So we've got 1 mole of sodium. There's not a number there, so it's interpreted as 1. We've got 1 mole of oxygen and 1 mole of hydrogen. So those are the 3 elements in the formula for sodium hydroxide. Okay, we're going to multiply each with the mass on the periodic table. So sodium is 22.99. Oxygen, which I didn't round this time on the periodic table. So again, using the periodic table. So our oxygen, right there, 15.999. And then our hydrogen, 1.008. And again, this is where I'm getting those numbers. So multiply the number of moles by that amount. Get your answer for each one. And then at the end, add them all up. And voila, that's your molar mass for sodium hydroxide. Okay, so now we're going to do something with that number like we did before. Remember that they tell us that we have 965 grams of sodium hydroxide. Remember that there's this many grams per 1 mole. So we're going to use dimensional analysis. Since this is grams, keep in mind, diagonally, this better be the same thing, grams. And sure enough, it is. Okay, so we use a 39.997 grams of sodium hydroxide per 1 mole. That allows us to cancel like units right there. Mathematically, 965 gets multiplied by 1. And then divided by 39.997. Enter it into your calculator, and it gives you the number of moles, 24.13 moles of sodium hydroxide. Granted that on the Nearpod that's being given to you, it says 24.1, which it was only rounded to the 10th. It doesn't matter. I like rounding it to the hundredths, so either way, but pretty much the same one, same answer. Okay. All right. So now that I have moles, what do we do? All right. So this is the information that I have. I converted that 965 grams to moles. I know that it's 24.13 moles of sodium hydroxide, which is what I need to replace here. And then I've got my molarity, which I'm going to go ahead and place down here. I divide the 2, and that's going to give me the liters of solution. Okay, so 24.13 moles divided by 1.5. And because I want to show you how this cancels, I'm not going to use the M as its unit, but rather the moles per liter. And you're going to find out when I do that, I could see that these moles get canceled with these moles, and the remaining unit is liters. So that's what I want in my answer. So once I do that, I calculate and I get some number like 16.08666. It keeps going liters, right? Like I said, I like rounding to nearest hundredth, so I'm going to round that. So this 6 kind of kicks off another number here, making it a 9, okay, because it's greater than 5. So I'm going to round it to 16.09 liters. And that's my answer. Okay, moving along, example 3. Calculate the number of moles of sodium hydroxide needed to prepare 1 liter of 1.50 molar solution. Okay, same thing. We have 3 variables, right? This one's a little easier because there's no conversions of mass to moles, and it's a little bit more straightforward, okay? So we know we have 1.50 for M. It says calculate the number of moles. That's our unknown. And then it tells us that we have 1 liter. So that's our liters of solution. Okay, so since moles is my unknown, I know that moles is equal to molarity times liters. Pretty simple. So it's pretty much going to be this times this. Voila. Pretty simple on this one. 1.50 moles per liter times 1 liter. Okay, liters cancels. Moles is a remaining unit. And my answer is 1.50 moles of sodium hydroxide. And that is our answer for that. Okay, example 4. It says calculate the mass of sodium hydroxide needed to prepare 1 liter of a 1.50 molar solution. All right, so interesting. This time, they're asking us to find mass. Okay, we still need our 3 variables, except this time, we're going to convert those moles to grams, okay? Okay, and this is how we're going to place everything. So we know that they gave us 1.50 molar for molarity. And again, this is kind of the same one we did earlier, okay? It's still the same information if you recall from the previous example. Okay, so they're giving us this variable, they give us this variable, we're asked to find moles. Okay, no big deal. Remember, it was 1.50 moles of sodium hydroxide. But now, what we've got to do is convert that 1.50 moles of sodium hydroxide to grams, because that's what the question is asking us to do. Okay, so when dealing with grams or mass, we've got to calculate the molar mass of sodium hydroxide, which we, again, did in the previous example. And we know that it's 39.997, as we saw before, right? Okay. So we know that the moles are 1.50 moles of sodium hydroxide. If this is moles, diagonally, this has to be moles. And since it's grams per moles, the grams will be on the top. Okay. We multiply the 2 top numbers, so 1.50 times 39.997 divided by 1, and our answer comes out to 59.995 grams, which, again, we can go ahead and round. And in this case, the 5 rounds at 9 to a 10, the 10 rounds at 9 to a 10, and then that rounds at 9 to a 10, rounding this to a 6. So 60 grams of sodium hydroxide is our answer for this example. Okay, so now we're going to move on to dilution. So what is a dilution? Okay, a dilution, according to the definition that was given to you, it's a process of decreasing the concentration of a stock solution. Our stock solution is usually meant as our original solution, okay, by adding more solvent to the solution. And our solvent would be, for example, like water. So adding more water to the Kool-Aid, okay? So let's take a look at the picture. Okay, as you can see, these particles represent the solute, okay? So if I add more water, you see how this is being diluted. There's a lot more water and you only have these little 5 particles floating around. And the more water you add, again, it's more diluted. Okay, so when dealing with the equation for dilutions, it's going to be M1 times V1 is equal to M2 times V2. So M1 stands for the molarity of the stock solution. V1 is the volume of the stock solution. Keep in mind, again, the stock solution is the original solution. M2 is the molarity of the diluted solution. And V2 is the volume of the diluted solution in this particular case. So just to make it a little easier for you guys, what are the different variations of this particular equation? Okay, well, it's nothing difficult, guys, and I don't want you to think of it as 1,000,001 different types of equations or formulas for the same one. All it is that I'm showing you how to break it down. Okay, so if I'm trying to look for a molarity 1, M1, all I have to do is take whatever's in my way and bring it down here. So molarity 1 is equal to molarity 2 times volume 2 over volume 1. If I'm trying to look for volume 1, okay, here's volume 1. All I do is take molarity 1 underneath, and this is the expressed way of finding it. Okay, same thing for the other ones. If I'm trying to find M2, guess what? V2's in my way. Stick it on the bottom. So M1 times V1 is over V2. If I'm trying to find V2, M2 is in the way. Stick it on the bottom. So again, M1 times V1 over M2. And that's pretty much the variations that we're going to deal with. Okay, for our first example of dilutions, it says, if I add 25 milliliters of water to 125 milliliters of a 0.15 or 0.150 molar sodium hydroxide solution, what will be the molarity of the diluted solution? Okay, to be honest with you, I'm very visual, and I like to see how this story plays out. And I drew a picture for you guys. So here we go. Let's see what our story is saying. All right, so what I'm understanding, all right, it says we have this solution. It's 125 milliliter of this concentration solution, okay? That's our stock solution, again, our original. And then in our little story, it says, if I add 25 milliliters of water. So I'm imagining that I'm taking this water and adding it to this. So if I add 25 milliliters of water, I no longer have 125 milliliters. I'm going to add those 25 milliliters to the 125. So now I have 150 milliliters. So that's my now diluted solution, okay, or V2, my diluted volume. And now I need to find out what is the concentration now that I've diluted this, okay? And then I'm just going to go ahead and put the variables. So I know that M1, our stock solution was 0.150 molar. Volume 1 was 125 milliliters. Volume 2, 150. And then we have the second molarity, which we don't know. All right, so we can pretty much say that we're trying to find M2. And remember from the variations that I showed you earlier, okay, if I'm trying to find M2, I can simply look down. And it would probably be a good idea to write these down for yourselves. Again, the good thing about this video is you can forward, rewind, stop, pause, whatever the case may be, and go at your own pace. But they are here, you can write them down. Okay, so I'm trying to look for M2. And remember, it's from this original formula. And I know it's going to be M1 times V1 over V2. So I already have these listed out. All I'm going to do is substitute the variables with the numerical values. Here you go. So that gets substituted by 0.150 molar times volume 1, 125 milliliters. All that divided by 150 milliliters, which is volume 2. Put that in your calculator. You should end up with 0.125 molar. So that is that would be our molarity for our diluted solution. And that's obviously our answer. Okay, for our second example, it says if I add water to 100 milliliters of 0.150 molar sodium hydroxide solution until the final volume is 150 milliliters, what will be the molarity of the diluted solution? Okay, so again, I'm going to visualize it, draw a picture, see what I have. Okay, this is what they're giving me. All right, so it says that I have, let's look at my stock solution. So I have a concentrated solution of 0.150 molar sodium hydroxide. It tells me that there's 100 milliliters of it. Okay, so that's my stock solution again. And it says if I add water to it, and then that makes another, or a diluted solution that now has a volume of 150. So if we kind of look at what the story is telling us, it was at 100. So that means that we added 50 milliliters of water, right? It doesn't tell us here, but that's how much it was added, because it says that it's the final volume. So now we have this diluted solution of 150 milliliters. So what would be the molarity? Okay, so I'm going to write down all my variables. Okay, that's M1, that's V1, M2, I don't know, V2 is 150 milliliters. Okay, something I forgot to add, and I needed to say that earlier in the first example. Notice that I've been telling you to work with liters when we did the concentration. But when you're doing dilutions, guys, you can go ahead and put them in milliliters. It's okay to use milliliters, but they both volumes have to have the same units. So if this were liters, this can be milliliters. Either both of them have to be liters or both of them have to be milliliters. Okay, so if both of them are milliliters, then you're good. No problems. Let's say that you're trying to find V2 and you're given milliliters, then keep in mind that when you calculate it, what's going to happen is you're going to calculate a number in milliliters, okay? But like I said, no problem if you're using the same unit. Just make sure you keep it consistent, okay? So anyways, let's go ahead and place it into our equation. So we're looking for M2. M2 is equal to M1 times V1 over V2. Substitute that by the numbers. Okay, here we go. That's going to be 0.150 molarity times 100 milliliters divided by 150 milliliters. Okay, so now use our calculator and our answer comes out to 0.1 molar. Okay, guys, sorry, I know that was kind of lengthy, and again, the other chemistry teachers and myself, we're trying to give you as much information as we can and being a lot more thorough. So I'm hoping that this helps, but again, any questions that you may have, just let us know, guys. We are thinking about you guys, and we always do whatever's in the best interest. Stay safe, guys. Stay healthy, and see you guys later.